Hi, my name is Muhammad Arif Al-Amin bin Hamidi, and today I will be simulating Visual Minteq. So first of all, we need to run the Visual Minteq. After that, we need to set up the parameters in the Visual Minteq, which is at parameters, and go to various default setting. And then if you can see, we need to choose the number of iteration to maximum, which is 5,000. And the method activity correction is Davis, and its parameter is 0.3. And we need to also choose the basis input concentration in solution. And we need to tick our saturated solids are allowed to precipitate each time a mineral precipitates or dissolves. So click save and continue. The next one is we need to set the pH to calculate from mass and charge balance. And the concentration unit that we need to use is molar. So from the question, it said that we need to simulate a titration of 5 meter cube acidic wastewater with 3 molar of NaO of sodium hydroxide in 25 liter increment. So first, we need to choose our components. So from the drop down here, need to choose H plus 1, and the total concentration is 2. So add to list. And after that, we need to choose our second component, which is SO4 minus 2. So the total concentration is 1 molar. And then we need to check via edit list. So we have everything set up. And then for titration, we need to choose the multi-problem or sweep menu. And then at this, we need to tick titration and go to titration manager. So at the titration manager, we need to set up the volume of solution to be titrated, which is in the question, we have 5 meter cubic. So we need to change the 5 meter cubic into liter. 5,000. So the volume of Tetran, in the question, it said that we need to use 25 liter increment. So in the 25 liter increment, and then the unit is mole per liter. We need to check this box for no Triton is to be added until the second step. So on the component side, we need to choose our sodium hydroxide because in our question, it needs 3 molar of NaO to neutralize the acidic wastewater. So click on NaO, click on sodium, and the concentration is 3 molar. Save and next. And then we need to state the number of titration step, which is 210, because from the volume of solution to be titrated, we need to divide it by the volume of titrant, which is 5,000 liter divided by 25 liter. And then we got 200, but we need to add extra 10 so that the pH will be more alkaline. So we need to click save and back, and then we are ready for run the Minteq. So we got the result. The pH will be 0.088, and the charge difference is negligible, 0.0008. So as we can see, we should click at the sweep selected sweep result, so we can see the pH of every times that the titrant were added. So the last 210 is the pH is 13.457, and then we need to print it to the Excel. So I have prepared the graph and the calculation of the. I have plot the titration curve of NaOH volume on the x-axis and the pH on the y-axis. So as you can see, the pH is on the y-axis, and then volume of sodium hydroxide, 3 molar sodium hydroxide will be at the x-axis. So this is this is our equivalent point, which is at 3,350 liter of NaOH. It will neutralize the sulfuric acid, which is H2SO4. So on our calculation side, we know that 1 molar H2SO4 is meaning that 1 liter of wastewater contains 1 mole of H2SO4. So after derivation, I've got 5,000 liter times 1 mole of H2SO4 per over is divided by 1 liter. So we get the number of mole of H2SO4. So we get 5,000 mole of H2SO4, and we know that in 5,000 liter of wastewater, it contains 5,000 mole of H2SO4. And then the next step, we need to multiply the number of mole with the molecular weight of H2SO4. Because in the calculation, in the graph, we can see that the volume of NaOH is at 300 and 350 to neutralize the 5 meter cubic. So on calculation side, we got 5,000 H2SO4 multiplied by 98 gram per mole, which is the molecular weight of H2SO4, and we get 490,000 gram of H2SO4. So the next step is we need to balance the equation of H2SO4 reacted with sodium hydroxide, which is 2 mole of sodium hydroxide react with 1 mole of H2SO4, and we will get Na2SO4 plus water. So we need to multiply the stoichiometry coefficient with the molecular weight, and after that we need to calculate the mass of NaOH, which in our case we need to calculate the mass of sodium hydroxide to neutralize the 5 cubic meter of acidic wastewater. So we have calculated just now, we get 490,000 gram of H2SO4. So after derivation, we need to multiply the 80 gram multiplied by 490,000 gram divided by 98 gram. So we got 400,000 gram, which is when we converted in kilogram, we got 400 kilogram of H2SO4, which is this is the mass that are required for neutralizing the 5 meter cubic of acidic wastewater. So I think that's all from me. Thank you.